Hi, I'm Tom Shields, and in today's Intelligence Report, we're going to talk about the data team, their role in preparing data sets for AI, and ideas for simplifying and accelerating their work. Here with me today are Krish and Russell. Thanks, guys, for coming. And we're going to discuss techniques to accelerate data preparation and integration. And let me frame the discussion with a quote. We do qualitative surveys periodically, and I've got one from a data engineering leader, in fact. To overcome challenges, we'll need to streamline integration of data between different cloud platforms and data storage services to reduce latency and complexity. So as a vendor, how are we bringing the data team into our design thinking and addressing the types of challenges that you saw in that quote there? What's needed based on our discussions with customers? We've been doing a lot of that. So tell me what you think, Krish.
Yeah, I like that you had a quote from a data engineering leader. So I'm going to throw a statistic back at you.
Okay. Hit me.
So 27% of the AI projects, they never graduate from POC phase into production. They never deliver the value, the promised value that these projects have, because it's incredibly hard to get enterprise data AI ready. And what do I mean by getting the data AI ready, right? These engineers spend 80% of the time moving the data, preparing the data, making sure the data has the right quality, they understand the lineage of the data, and they bring it all together. So as part of this process, the data moves from one environment to the other environment to the other. Our customers told us sometimes they end up making 7 copies of the data before they are done preparing it for AI, right? And some of this data movement is to their data lakes. Some of it is actually moving from traditional data lakes into cloud environments, depending on where they're doing inferencing or training. So the data problem is an actually meaningful problem. Solving for that data mobility, that seamless movement that you were talking about between on-prem and cloud is a complex challenge. And as a vendor, what can you do? Right? I think if you think about that one, it all starts with being able to give a unified global namespace, an ability to look at this data wherever the data set is at in a consistent and unified way. Once you do that, you can now query the data, you can build your workflows on top of the data, and you can build triggers so that you're actually very efficient with how the data gets moved.
And you're talking about data spread, throughout the data estate. Some's on-premise, some's out in different clouds, different managed hosting environments. And this is just a single view.
It's not just a cost issue. This is one of these really interesting situations where it's pretty obvious that copying data 6 times is not a good thing from a cost perspective. But it's not just a cost perspective. It actually hinders the work of the data engineer in actually gathering data together. So this is one of those interesting situations where there's a happy coincidence of being able to save and be more efficient with money and cost and operations, et cetera, but also make the lives of these data engineers easier and faster. And then, Krish was talking about, how these projects don't get out of PSC. And one of the reasons is that just imagine 6 different data environments, each with their own governance and security policies, different formats, different APIs. The complexity of data engineering is huge. And frankly, I think we have a vision that there will be times when you shouldn't have to use a data engineer. It's so complex today that data engineering is a big problem. I think we have a vision that it shouldn't need to be that complex.
Yeah, the way to reduce the complexity is the more you can actually help get that enterprise data AI ready in place being the key word. Like, the more data movement you eliminate from these complex workflows, the more consistent the toolkit is between how the data moves between these different environments. I think the life of a data engineer gets better because the complexity, to Russell's point, gets taken away. Your goal as a vendor is to help, cost savings are great, but it's actually even more importantly, data engineers are your most expensive resource here. So the ability to help them and make them more efficient, to me, actually is even better than just the straightforward cost savings.
And doing it, and this is a great point, Chris, and doing it in a way that doesn't cause problems from a data governance perspective. One of the challenges that these customers have is these different groups have their different sets of data. Yep. They have their own controls in place. In a POC environment, to your point, they're willing to give people data samples and say, go at it, right? But when it actually comes to, hey, this is live data that's going to be streaming and you're going to be taking this data and doing something else with it, it's a big problem. And we're starting to see an evolution of regulations on how customers manage that data. I think probably most interesting is the AI Act from the European Union, which came into force in August of 2024. And, there are some pretty specific things that companies and now organizations are expected to do and to adhere to. And there's going to be a significant amount of fear of am I going to allow this to happen, or am I going to take the easier route and just not do it at all?
Yeah, actually, that's a great point, right? And I think this is kind of why I'm very, very, opinionated and focused on doing as much of this data readiness in place as possible. Because when you do the enterprise data readiness for AI in place, you're actually not changing your policy posture, your compliance posture. So Russell, new regulations would come in. As you comply with it, you don't want to comply with it across 4 different environments or 6 different environments. So the more you can do in place, the more compliant you stay.
Yeah, it sounds like less time and a much simpler workflow for a data engineer is what we're aiming for. I want to switch gears a little bit and talk about RAG and vector databases and how you're thinking about making that a little simpler for a customer.
Yeah, I'll actually talk about RAG first, and then we can talk about vector databases specifically. When you think about, retrieval augmented generation or RAG, you're mostly talking about how do I put a solution together for inferencing that's accounting for your, metadata, your changes to the metadata, your policy engine, your embeddings. How do you bring that all together? Your vector databases, how do you bring that all together so that, you can do inferencing? And the more you think of this one, the more inferencing you can do in place where you bring AI to where your data is so that you can respect the data gravity, the better off you are. So you hear us talk a lot about inferencing in a box. So what we mean by that is we're not trying to solve everything ourselves, but we want to embrace a solution where we want to work on things that are, strengths of the underlying data infrastructure, like vector DB optimizations. We want to do them in place, and that's actually more closer to the storage. But we don't need to invent vector databases because there are enough really good open source ones. So this is where you bring the ecosystem together. Like we talk a lot about, NVIDIA, NIMS, and NeMo integration. So all of these for us is how do we bring the best of what the ecosystem has to offer, knowing that we are your data stewards, putting those two together so that you can do that, inferencing in place closer to where the data is, and do it in a way where the AI comes to the data when it comes to RAG or inferencing.
Yeah, there's a really good example, just to add to what Chris was saying, about something that I've termed RAG-lag. The marketing guy. You guys don't love this much, but I call it.
That one needs some work.
I mean, it does need a little bit of work, but RAG-lag is really interesting, and I think it expands on something that Chris was talking about, which is that I think it's not a question of us doing everything; it's a question of us doing things that we can uniquely do better, right? And RAG-lag is one of those situations. So if you have in a retrieval augmented generation environment, you have a knowledge base that's sitting at the back, and that knowledge base is helping augment the large language model. And if that knowledge base is changing, then there is a pretty difficult job of going in, enumerating the data set, finding out what's changed, and generating a new vector embedding. And by the way, until you've done that, whatever you're asking, whatever you're prompting the RAG environment as an end user will be based on old data. Right now, there are lots of examples of where this might be a problem. Where there was a healthcare customer in Europe I was talking to who's using RAG to query patient records. And it's in a hospital environment. And they have a challenge that's a lot of records. And it actually takes them about 2 to 3 hours to enumerate the whole data set to find a change. So in that meantime, imagine that you've gone and had a blood test, and that blood test is now in your file, but the RAG system cannot see it because that data hasn't been triggered and no new vector embedding has been generated. That is a real world consequence of RAG lag, that lag between underlying data change and what is exposed to the RAG system. So if you can actually detect that at the storage level, which by the way, we absolutely can, then what you can do is you can actually do an almost inline revectorization of that content, and you remove
real-time revectorization.
Absolutely, but super efficient because you're not having to enumerate the whole data set.
I think the point Russell is making is a very important one, because when you're in this environment, you have millions of files, right? So if every single time any underlying data changes, you have to go back and revectorize everything, recreate the embeddings, it's going to create significant lag, RAG lag. We'll keep working on it. But actually there is a true lag if you have to revectorize and create embeddings for the entire data set. This is where, as a storage vendor, as a data infrastructure vendor, you can be incredibly smart. You can bring the technologies that will let you detect changes on a more granular basis and recreate those embeddings instantaneously for just the data that actually changed. Like I love your healthcare example. There's another example I was thinking of where, the actual cloud application talks to the vector database that's on-prem. And because of the size and cost, they decided to go with the architecture where, the underlying database is actually in the on-prem world. And now you have a 5-second latency in the application. So every insight as I'm working on the dock is delayed by 5 seconds. Now imagine the user workflow experience, when you build that latency into RAG.
Well, it sounds like there's a lot of benefit in doing it closer to the storage, doing it more efficiently and more real time.
Absolutely.
As you recompute these vector databases. So that'll be fun to see how that plays out here at NetApp. Hey, so you guys have been talking about vector databases, and I've heard this term of vector bloat. And what is that all about? Can we address it?
So actually, that's a great question, Tom. So let's talk about vector bloat. Right. So what happens as you are preparing your data for your inferencing workflows is that, you end up taking your unstructured data, object or file, and you're going to run it through a certain embedding models, right? And if you have multimodal embedding models, these are going to get even more complex. And you do that to be able to vectorize your data, and then you store it in a vector database so that your nearest neighbor searches are optimal, right, and are efficient. And why is this important? This is incredibly important because depending on the number of dimensions you choose, when you vectorize your data set, your vector databases tend up to be being significantly larger than your original data set. Many of our customers tell us the average size of their vector databases is about 8 to 10 times the original data set. This is hard, not just from a storage capacity perspective, but what I was talking about before with the nearest neighbor searches. What it means is in the middle of your application AI workflows, when you're doing those lookups on these databases, you want them to be in memory as much as possible. And memory is expensive. So not only the bloat affects the size on the disk, the bloat affects everything up the stack. How much of this data can be in memory? And that dictates the latencies that you have as an application. So vector bloat is real. It's incredibly important. And we are glad that, we can bring in some of our knowledge in how we pack the data on the disk in an efficient way, how we go do global dedupes, how we can compress the data so that, the bloat is not 8 to 10 times, but it's actually more closer to 1.6 to 1.8 times the original data set. So I think the problem is real. I think what we have as a solution is incredibly unique.
But this is a really good example of the difference between getting something to work in a POC environment and getting to work at scale. I mean, customers and organizations are looking at ROI calculations, right? That means benefit and cost. And what Krish is talking about is where you're able to get your vector bloat under control. You are going to be able to operate these inferencing farms at scale way cheaper.
Absolutely.
And way more performant than you would otherwise be able to. So it's interesting because these are the sorts of things that don't often get thought about early in the process because people are just trying to get things working.
Right. Back to your point on going from a POC to production.
Yeah.
I mean, being able to do it in a cost-effective way and not having the storage just expand to manage these vector databases as they grow and grow and grow.
And we're going to challenge organizations. I think all organizations are going to be challenged to not be thinking about this later in the phases. I mean, they need to be actually need to be designing and building this at the POC, at the inception stage.
Right.
And that, I think that's a key change in the industry. I think people have been happy just to run off, try stuff up, and that's not going to work.
When you start to pencil out the ROI, when you're going to production, it doesn't work.
Absolutely. Because the implications of something like this are across the stack.
Absolutely.
Right? There are costs involved, there are like memory considerations that you need to have, and there are actual latency considerations that will impact your application SLAs. So this is something, that you got to be thinking about ahead of time.
Yeah. I want to just change gears again in one final area. We've talked a lot, doing a lot of things closer to the storage. You're not talking about doing everything in the AI workflow. We still need an ecosystem, right? And just talk about our philosophy about the AI ecosystem and what's really important for us.
Yeah, I mean, so look, NetApp's had a long history of having this incredible ecosystem of partners. It's a strength, honestly, and I think customers appreciate the flexibility of being able to bring in vendors who are specialized in their space and having a great joint experience with NetApp. And that's not just a validated experience, that's actually an integrated experience where the two partners, when they work together, actually create a better outcome for the customer. AI is a really interesting one. And I think it's interesting because as a data engineer, what you're seeing is a rapidly evolving set of tools. I mean, I kid you not, weekly, these tools are changing. And we've seen parallels in, for example, DevOps, where, it isn't a single tool chain or a single data workflow. It is it's a number of different ones that might be specific to each project, and the ability to compose that in real time as needed. That's what data engineers do on an everyday basis, right? So how do you kind of take those two worlds, the idea that we want to do things close to the storage, but we also want to give people the flexibility. And the reality is there are some components where we can actually bring them next to the data, and it's better to do it next to the data, but they're integrated in a way that you can compose them as part of a wider workflow. And there's other pieces that, frankly, shouldn't necessarily sit next to the data, but can be integrated with APIs and other capabilities that are implicit in our data platforms that create a better experience. So,
yeah, I'll actually add two specific ecosystem things to add to what Russell is saying, right? When you think about cloud, a lot of data engineers like the toolkits that the hyperscalers have, right? Mm-hmm. Let it be Bedrock or the 59 services that they have in the AWS AI toolkit or ANF or, with GCP and, Vertex, so data engineers love to use the toolkit that they have in these hyperscalers. So in that context, what they want is the ability to actually tap into the underlying data and have the data be available to these toolkits in a very native fashion. I think that becomes incredibly important. When you think about on-prem, there are also cases, like to Russell's point, like on an average, we have seen 13 to 15 tools used by these data engineers. So how do you integrate with them so that, more and more of the data readiness can be done, closer to where the data is? How do you actually bring that, AI closer to the data? So one of the things we talk about a lot is bring your LLM, bring your toolkit, like we will get your data AI ready in place, right? So giving that optionality to customers becomes a very important thing.
It's hugely flexible, and I think it also probably reflects the reality that we can't predict the future. I'd love to be able to predict the future. I'd be a very rich man, right? If I could.
We're not.
But That's right. But I can't predict the future. What I do know is that if we go back even 2 years, generative AI wasn't really a big thing. So this idea that there's any sort of fixed tool chest that can be relied upon in the long run in this space is nonsense. I think that what organizations should be looking for is vendors that have had a track record of quickly adapting without fundamentally changing what they do. I think that's a critical mate.
Right, and I think NetApp with its ecosystem that spans different toolkits on-premise in the public cloud is in a great position. So we covered a lot of ground here in the data engineering area, and we talked about doing work closer to the data, doing it more efficiently, doing it faster, relieving some of the headaches that the data engineers experience on a daily basis. And so I think it's been a great discussion, and I think we're going to leave it there. I want to encourage folks to tune into the other intelligence reports in the series. We'll talk about the IT ops role and how we can help with some ideas on making data infrastructure more efficient, and also on the data science side and how we can work to make those guys more productive. We'll see you next time.